In France, there's a breathtaking structure known as the Millau Viaduct, the tallest bridge in the world. But what's truly fascinating isn't just its height, it's the nearly impossible engineering behind it. Ever wondered how engineers managed to build the massive pillars at exactly the same level across mountain slopes? Even the slightest mistake during construction could have caused the entire structure to collapse, wasting billions of dollars. So how did they pull it off? Let's explore the remarkable story behind this engineering marvel. The French government was under pressure to find a solution to severe traffic congestion. During the holiday season, tourists clogged the roads of nearly every major city. The solution? Build a massive bridge to connect key routes, one that could stand above it all. But this project came with three major challenges. Number 1. Constructing the tallest bridge pillars in the world on sloped, unstable mountain terrain. Number 2. Supporting a 36,000-ton 4-lane highway on those pillars. No 3. Adding steel pylons on top of the completed bridge for added structural integrity. The world-renowned architect Lord Norman Foster took on the project. His design included 7 tall pillars with a gracefully curved road deck to accommodate wind flow and maintain balance. The second pillar, located in the center, was the tallest, while the remaining 6 had to be built at precise heights on the sloping landscape. The deadline? Just 4 years. Any delay would cost the construction company $30,000 for each day they went over. Construction began by laying the foundation of the pillars, but geologists had already warned about the risk of landslides in the area, and sure enough, one occurred. A massive landslide buried the foundation of the first pillar. Fortunately, it wasn't damaged. The team quickly reinforced the slope with cement and resumed work. To meet the demands of the project, a full-scale cement factory was built on-site, producing over 200,000 tons of concrete for the pillars. But now came another challenge: precision. The pillars weren't simple cylinders, they were wider at the base and narrower at the top. If the pillars weren't placed within a centimeter of the correct location, the road deck wouldn't align. A mere 10-centimeter error at the base could lead to a 6-meter gap at the top. To solve this, engineers used multiple satellites to pinpoint the exact placement for each pillar. After 2 years of work, all 7 pillars were perfectly placed. Next came the even harder part: assembling and lifting a 2.5-kilometer-long 4-lane highway at extreme height. The road was divided into 2,200 heavy steel sections, each weighing about 90 tons. Transporting them to the site was a massive effort, requiring blocked highways and custom-built vehicles. Initially, the plan was to slide the welded sections across the pillars, but the gaps between the pillars were 342 meters, too wide to support the weight safely. If engineers tried to push the sections across as usual, they could collapse mid-air. That's when a senior engineer stepped in with a simple but genius demonstration. He placed a weight on a weak table and pushed it from underneath. It moved. Then he placed the same weight on top and tried pushing. It barely budged. Based on this principle, a special pushing system was developed to transfer the steel road sections horizontally without putting too much pressure on the pillars. Temporary steel supports were also installed between the pillars to distribute the weight evenly. A single miscalculation here would mean disaster, but everything went according to plan. One by one, the sections slid into place perfectly across 6 pillars. Finally, the last section, right above the river, had to be installed. If this final piece didn't fit perfectly, 4 years of effort would go to waste. As the slider button was pressed, the entire country held its breath. And then success. The last section aligned flawlessly. The Millau Viaduct was now complete, ahead of schedule. This awe-inspiring bridge isn't just the highest in the world, it's a triumph of precision, innovation, and human determination.